All right, CNT140, we're continuing our discussion on Chapter 4 on UTP. So with performance grades, with your categories, performance grades, sometimes you can easily see the difference, sometimes you can't. But we need to pay attention to, as we're working with this equipment, when it's rated for Category 5E, we know that's its capability, but we need to make sure that all of our pieces of equipment are the same. Category 5E cables, outlet jacks, patch panels, etc. Category 6. So I need to look for those identifiers and make sure that I'm using the right category of equipment as I'm doing installs. So, and they remind you here that, if I have Category 5E everywhere, but all of a sudden I start using Category 3 patch cables or whatever, my system's only going to be as strong as that weakest link. So I need to make sure I'm checking the rating on all my equipment and using the same category throughout. So my whole system, patch cables, outlet jacks, horizontal cabling, patch panels, patch cable, all need to be of the same category rating. So I'm looking for, on patch panels, Category 6. I'm looking for my horizontal cabling, boxes of cable, horizontal cabling be rated Category 6. I'm looking for my outlet jacks to be rated Category 6. I'm looking for my patch cables to be rated Category 6. So my whole system should be the same category. That way I'm ensuring that that is the performance level I should be able to achieve with this system. If I mix match in, it's going to be to that lowest category performance level. We also need to worry about our terminations. As we start working with higher frequency signals, the little things really start mattering. Having a little bit extra untwist on a termination could affect the performance. As I like to joke, because I'm a racing nerd, if I'm going to drive a car at 150, 200 miles an hour, the little things really do matter, that this machine is going to perform up to its capability. The same thing is going to be true in our cabling system. So my terminations, I really have to watch my ½ inch of untwist and not exceed that. Because if I think about it, I do a sloppy connection on the patch panel, sloppy connection on the outlet jack, sloppy connection on the patch cable, all that adds up over time and can really affect the overall performance, especially if I have an extra long patch cable or something too, adding an extra resistance plus the untwist and so forth. In the internationally, US we tend to use categories. Internationally they tend to use classes. So the book put out here kind of a correlation guide for you. So we look at 3, 5E, 6, so forth. Internationally, they look at class A, B, C, D, E, F. So a lot of times you're going to see, when you look at specifications, you'll see both of these identifiers. And that's where, if you need to, look at a chart so you know how to reference them, how to line them up. So, stuff like that you would know to look for. And here they also start showing all the performance grades with 5, 5E, 6, and so forth, what it's able to support, frequency range, length, compatibility, and so forth. And then what type of field test equipment you would need, what level of field test equipment you would need to test and certify that installed category of cabling. Again, each standard includes all the cables, jacks, plugs, etc., everything you need to install that. But using, let's say I only need gigabit, but if so I could get by with 5E, but it would probably be wise to do 6 or 6A, so I have extra room. I'm not running at the absolute capacity of that cabling, but I also have room that if I want to upgrade later, I already have the cabling in place that will handle it. So that's one of those things about thinking down the road. Installing maybe a category better to give us some room, or also room to increase our bandwidth too. That's what they talk about, the headroom. They talk real quickly about access points and how access points were needing more than 1 gig. So they were actually developing the electronics to operate over the 5E cabling that existed. So you could have a newer wireless network using older legacy cabling, if you will. So things along the line have developed to progress, but use existing equipment instead of having to tear all the cabling and everything out. Leap in technology advance comes with a cost. The goal of your standards committee was each category of cable rated should be backwards compatible, meaning if it works on 5E, it should be able to also work on Category 6. I wouldn't need to replace it just to plug it into a Category 6 network. Also, the other goal was interoperability. So if I use a patch cable from one manufacturer, I should be able to plug it into a different manufacturer's outlet jack and have it work and so forth. Initially, you had a lot of issues with, I had to use this brand outlet jack with this brand faceplate and this brand box and so forth. It is getting better, but you still do run into some of those little niches where I might need to have this manufacturer faceplate and outlet jack, but I can use a different manufacturer cabling, different manufacturing patch cable. Third goal, again, compatibility between manufacturers, which is kind of what I just got done mentioning for you. Being able to have some interoperability with some of this stuff. At one point, it was very proprietary, so a little bit better compatibility today. Category 8, as we said before, you have shooting around each pair and then shooting around all 8 wires to be able to have the higher bandwidth signals, higher frequency signals through, giving me higher bandwidth. Usually you would find in data centers for high bandwidth short distance connections. Working with screen twisted pair and shielded twisted pair, I would say recognize these as, your shielded twisted pair. Each pair is getting shielded individually. This is the kind of the root of this was your token ring networks and the shielded twisted pair cabling. But you start seeing this technology in higher categories of cabling. And same thing with screen twisted pair. Screen twisted pair, you have shielding around just all 8 wires. This got introduced when you start working with category 6 and 6A and so forth. You start adding in this technology to give you the higher frequencies you can send through to be able to send more bandwidth through. So recognizing that those are what they are, and I think this is exactly what it's saying here with our introduction of category 6, 6A, and so forth, adding in those technologies to get the higher bandwidth signal. And here's 6A. We actually have the plastic divider between the pairs, and then foil shield around all pairs. That's your screen twisted pair. And I do need to worry about if I'm using that type of technology, that shielding needs to get connected to the appropriate outlet jack and modulator pin connector that will connect to that shielding and actually be able to ground that out. Any signal that's any interference that is picked up by that shielding, we need to ground it out and get rid of it so it does not affect the data signal in the cabling. So you would need to make sure you're using the appropriate connectors to do so. As we talk on shielded twisted pair, we need to talk about flammability. We mentioned this back in, I think it might have been like chapter 1, 2. I at least kind of got you introduced to the idea of this. Here they're giving you some more details. When I'm dealing with cabling, the jacket around inside the cable can be made of different type of plastics. So therefore, if it were to catch on fire, one type of plastic, ordinary, PVC plastic around your general cable, as that catches fire, it's going to burn and emit. If you've ever seen plastic in a campfire or something, you tend to see a lot of black smoke or maybe even some like green flames in there. Those are toxic fumes. Okay, so the jacket around a cable can be made of different types of plastics. Some that are, if they were to burn, emit a lot of toxic fumes, but other insulations are designed, not that they're fireproof, but if they do catch on fire, they're not emitting that high level of toxic fumes. It might be extremely low or near zero, if you will. So that's when we come into the flammability ratings. Well, the easiest thing to do is look at that last letter. If I look at the last letter, it'll let me know whether it's general, riser, or plenum. So if I look at some pictures, I have an office here or a computer lab here, or a teacher's classroom here kind of thing. Any cabling that I'm installing above the ceiling in like the suspended ceiling space to go from closet, down the hallway, above the ceiling, down the hallway and into a room. If it's going through this space up here, it needs to be plenum rated. So that cabling there, I would need to be looking for a CMP plenum rating on the cabling. If it is going to be installed between a closet on this floor and the data closet on the floor above it, if I'm going vertically between the closets, I need at least to be riser rated, CMR, riser rated, R for riser. If I'm just connecting a patch cable out here at the desk, just in this room, it can be general purpose, CMG, or they use CMX here. CMX and CMG you'll see. Here's another picture of the same kind of idea. Between floors, closet here to closet there, or closet here to closet there would need to be riser rated, CMR. Out in the general connection at the work desk here, patch cable out here can be CMG. And above the ceiling, any horizontal cabling above the ceiling would need to be plenum rated, CMP plenum rated. So as I look at my cabling, I'm looking at the box, and if I look at the box, it'll let me know. This right here is just CM rated. This would be patch cable material. Okay, that can only be used as a patch cable in a room. If I see CMR, I know it's riser rated, and I can actually use this to connect the closet here on the first floor to the closet on the second floor right above us. The third one down here, plenum rated, CMP plenum rated. This can now get used installed above the ceilings as horizontal cabling out to a work area. So I'm looking for a plenum rating on the box or CMP on the outside jacket. As I'm pulling network cabling, and we talked about this a little bit when we did our horizontal cabling lab, I need to make sure I'm handling it kind of gently and making sure that I don't have any sharp bends. I don't kink the cable. Any bending or kinking the cable, the wires inside, those wires twist together inside, actually start flattening out, and you're kind of, for a brief little slice of distance, you're negating the twisting of those wire pairs. I'm not going to use any sharp cable, tightly bundled cable ties like the plastic cable ties. I do want to try to use the Velcro ties that I can open and close, add to, remove, but it's not going to be a sharp, tight bundle on the cable where I might do damage to the cable inside, either the jack or the cable inside. Here we remember about any of our outlet jacks or our modulator pin connectors or our outlet jacks are actually terminated with those terminations are insulation displacement connections, IDCs. These insulation displacement connections actually cut through the outer jacket of the cable and make contact with the copper wire inside. So as I look at the terminations here on the patch panel, those on the back are insulation displacement connectors. The outlet jacks here, as I punch into them or snap the cover shut, those are insulation displacement connectors, and even the modulate pin connectors that we use to make patch cables. So over here on the stranded patch cable, stranded cable for patch cables, if I look at the modulate pin connectors, if I kind of break them apart, I find that there's these little brass pins in here. Well, those little brass pins have teeth on that when I crimp them, when I crimp the connector, those pins get pushed in, cut through the insulation, make contact with the copper wire inside. That's insulation displacement connector. As far as the horizontal cabling, that is to solid wire. Okay, that is the solid conductor wire. That is typically terminated into an outlet jack like so. I punch it in, and inside that outlet jack there's like a little metal V that the wire is punched into. The metal V cuts the insulation on the outside to make contact with a copper wire on the inside. On the other end of my horizontal cabling, we have a patch panel. The patch panel itself has that same type of termination on the back. When I punch the wires into it, it has the same type of termination here. So again, they remind us, make sure the rating is the same on all. 6 on the patch panel, 6 on the cabling, the horizontal cabling, 6 on the outlet jack, 6 on the patch cable, and so forth. All the components should be the same rating, so that it'll function as it's supposed to, up to the performance level that you want it to. And as I'm terminating, I need to make sure I'm following the color code on my outlet jacks. And as we do termination outlet jacks, we'll look at those a little closer. But they are printed for both A and B. So I need to follow the rating on the side of the jack, or the color code on the side of the jack, to know which order I'm punching my wires into. And the same thing will be true with our patch cables, the modulate pin connectors. There is 2 color code pinouts, A and B. I would need to follow the color code order I need for my site. Okay. When we come back, we'll continue on with the color code with some of the other components we encounter.